Hi and welcome to a new 3DEqualizer4 tutorial. In this video we show a variety of new lens distortion features coming with release 7.1. Recently it was brought to our attention that certain anamorphic lenses can cause problems in 3DE4. After a bit of research, we found the most common culprit. The P&S Technic Technovision 40 to 70mm zoom lens. Most problems show up within the 40mm range. If we check the History tab on the P&S website, we find this. Launch of the modern version of the famous Technovision anamorphic lenses. These lenses combine modern technology with a vintage Technovision character, which is commonly being wanted by quite a few filmmakers nowadays. But what does this mean in practice? Let's take a look at this example. This grid shot was taken at 40mm. You can see the extreme distortion towards the edges. When we zoom in and select a bunch of checkerboard pieces, we can see that the center has a somewhat acceptable aspect ratio. However, if we move closer to the edges and select some pieces again, the aspect ratio is becoming quite extreme. As you can see, the matrix has already been set. Let's try 3DE's regular anamorphic degree 4 distortion model first. After calculating everything, we already see that there is a deviation of more than 14 pixels. That's way too much. Let's enable 3DE's distortion grid and align it as good as possible. After centering the red lines of the grid, we try to adjust its scale. But no matter how hard we try, it's impossible to properly align it. There's only a small area in the center we can manage to fit. Obviously, our trusty old degree 4 model is not able to handle this type of distortion properly. At least not within the low 40mm range. Instead, we decided to introduce a new pair of anamorphic degree 6 lens distortion models. It's equipped with a whole set of degree 6 parameters plus the regular lens rotation and squeeze X and Y parameters. 3DE is now capable to deal with such extreme types of anamorphic lenses. Let's take a look at what happens if we activate it. If we now calculate lens parameter again, the deviation is down to 5 pixels. Scaling the grid is way easier now as well. Some errors are of course still bound to happen, because the checkerboard wasn't set up completely straight in respect to the camera, as you might be able to see in the bottom left corner. Aside from that though, we can now adjust the grid to a very close fit. If we underdistort our grid shot, we can see the full power of the new model. The lines are close to perfect, both horizontally and vertically. It is now possible to easily work with these new modern retro vintage lenses. For our next topic, let us talk about Zeiss extended metadata files. This grid shot sequence has been provided by Zeiss. It's a 40 frames long focus pull in OpenEXR format. If we turn on the distortion grid and zoom into a corner, we can see that the grid and the checkerboard edges are not parallel and slightly drifting apart, so there's a little bit of distortion. Let's have a quick look at the embedded metadata, which is included with these OpenEXR files. For this purpose, we use a custom script developed by Pacha Saheb. The attribute of interest here is timecode, which is necessary for a proper synchronization of footage and external metadata files later on. 3DE's import menu now provides a new entry, Import Zeiss Extended Metadata. This script opens a requester for importing so-called ZLCF metadata files. A ZLCF metadata file includes data for every frame of a sequence, like focus, focal length, and also lens distortion information. Now let's select a matching ZLCF file, which has been recorded by the camera rig while shooting this sequence. Besides selecting a ZLCF file, this script provides a few additional options as well, like synchronization. Thanks to the above-mentioned timecode attributes, we can easily build a corresponding relationship between the embedded metadata of the footage and ZLCF file data. Therefore, we leave this option menu to Automatic. However, if there are no OpenEXR files or no embedded timecode attributes, it will be nearly impossible to synchronize footage and extended metadata properly. In such a case, you will have to choose manually frame offset and enter an offset by hand. Again, this workflow is very error-bound and will mean a lot of trouble, so you will most likely not want to use it. Finally, the requester allows you to choose which data to import. You generally will always want to import lens distortion. If a zoom lens was used, it is also a good idea to check focal length as well. Unfortunately, you cannot import lens distortion and focus distance together. We explain why later. For this project we need lens distortion, so we only check this one and import the file. Now the script imports the ZLCF data and converts it into 3DE's radial standard degree 4 distortion model. The first thing we will notice is that the blue distortion grid has become slightly curved, and 3DE's display distortion script now shows some non-zero numbers. And while at first glance we can't see anything else that's new, something else has changed as well. If we zoom back into the corner we looked at a few minutes ago and play back the sequence again, the distortion grid is now in motion. For a better view, let us move the grid onto a simple color background and play back the sequence again. See how the blue line moves away from the mouse icon? Now we can quickly adjust the grid onto the checkerboard, and it seems that distortion has been imported correctly. Since ZLCF files are supposed to contain distortion data on a frame-by-frame basis, it is necessary to enable dynamic distortion. The script does that automatically. In addition, it generates a fitting ramp-up focus distance curve so that all distortion curves will now behave as pure animation curves. If we zoom closer to one of the distortion curves, it becomes obvious that the embedded metadata isn't perfect, unfortunately. It seems that the lens's hardware can only record a data point every few frames, and as a consequence, the curve looks quite jaggy. If you choose to click on Edit and open the Filter Curve script, you can smooth it out though. It's possible to repeat applying the filter until you have a curve that pleases you. However, this filter edits the metadata. There is a chance that this might interfere with later steps in the pipeline. Please choose wisely before you add such a filter operation. Our next topic covers a major update for our script Import Multiple Reference Frames, which has been rewritten entirely from scratch. Keep your eyes peeled for a new, way easier and faster workflow. Let's start with a simple task. First, we want to import a series of regular reference frames. For that, we head to the Import menu and select Import Multiple Reference Frames, which opens up a new requester. As you can see, there are a ton of new options which we will discuss in detail throughout the following steps. In order to tell the script which footage we wish to import, we click on Add and search for the files we need. An updated preview image helps us to select the needed frames. The updated file requester of release 7.1 now allows to select multiple files at once by holding down Shift or Ctrl while clicking in the list. As you would expect, click-drag selection is possible as well. After we hit OK, the selected frames are being added to the requester. Since these images are just regular reference frames, we can ignore all remaining options for now and simply hit Import. Now the frames are being imported and we can check them in the timeline. Quite simple, isn't it? Let's move on to a more complicated task, which is importing a series of grid shots. We once again select Import Multiple Reference Frames and add 5 classic distortion grids to the requester window. This time, we not only want to import the footage, but we also want to calculate distortion, fully automatically. For this purpose, we have to choose one out of 4 possible automatic distortion calculation options. We select option number 1, which will create a separate lens object for each to be created reference camera. It is always a good idea to go through all options and check if everything is correct. Since these are grid shots taken with a radial lens, we select radial standard degree 4 as our intended distortion model. Film back height as well as lens center offset can be left at default values. Pixel aspect of lens and footage is 1, so we can leave those at their default values as well. These 5 parameters are always being applied to all imported frames. However, parameters focal length, focus distance, and multi-resolution grid can be set for each frame individually. For this example, we only have information about the focal length, so we select the list entry of each frame and update its focal length setting manually. Please note that some OpenEXR files contain embedded metadata for focal length and/or focus distance. In such a case, this data will be imported automatically already when adding footage to the requester. After we are done, we hit Import again. The grid shots are being imported one by one, and at the same time its distortion is being calculated as well. After this process has been finished, we can see that everything has been imported correctly. When checking the lens attributes, we can also see that distortion values have been calculated and added properly. The matrix has been set as well, and once we undistort the frames, we can see that our distortion calculation has succeeded. Just like intended. But of course, this isn't all yet. Let's go on with something even more elaborate. Our next distortion example will demonstrate how to create a single lens with dynamic distortion out of a series of anamorphic grids. Let's start by importing all Iskorama 75mm grid shots, which we used for our original lens breathing tutorial a few years ago. First, we changed the order of the files by click-dragging some selected entries with the middle mouse button so that focus distance increases from top to bottom. Next, we set automatic distortion calculation to single lens dynamic distortion driven by focus distance only. Since this is anamorphic footage shot by an analog film camera, we select distortion model Anamorphic standard degree 4 and set lens center offset X to 0.26 cm. The squeeze ratio of the lens has been 2:1, and therefore we have to enter 2 into the respective text field. The footage has not been unsqueezed or otherwise modified, therefore we set production pixel aspect to 2 as well. Please note that if for some reason the footage has a different pixel aspect than the squeeze ratio of the lens, this script will automatically switch to the rescaled version of 3DE's Anamorphic degree 4 distortion model and set parameter rescale accordingly. Now we need to update focal length, and for each frame focus distance, as already shown in the previous example. This might take a moment to fill out, but trust me on this, it's the only complicated step. Finally, we can hit Import. Importing and calculating runs on your GPU, so it depends on your graphic card how fast it will calculate. After the import process has been completed, we see a massive lens breathing effect, typical for these grid shots. The matrix for each frame is set as well. Enabling undistort shows a pretty good result already, but there's still an annoying zoom or lens breathing effect caused by the changing focus. Finally, we can also see that dynamic distortion has been set to driven by focus distance only. Just like in the original tutorial, we want to get rid of lens breathing entirely. To do so, select curves Squeeze X and Y in Curve Editor and delete their first default CVs. Now we select all the frames in the object browser and run script normalize Squeeze XY for focus-driven anamorphic. Both curves now have flipped completely, and once we scrub through the timeline, we can see that any lens breathing effects now have been almost entirely eliminated. This wasn't it yet though. We still have even more updates for you. Remember our new anamorphic degree 6 distortion model? Let's try importing the 40mm Technovision grid shot demonstrated in the first part of this tutorial. We enable automatic distortion calculation, choose Anamorphic standard degree 6 as our distortion model and enter 1.5 into both pixel aspect text fields. For now we keep our hands off the quality slider though and stick to its default value of 0. After importing it, we check the matrix, check the undistorted values and see, well, nothing that special. It looks good. Now we import the file again. But this time we push the slider to maximum quality. Keep in mind again though, that calculation will take more time on higher quality levels. We can see that there is a significant difference, especially towards the distorted edges. Overall though, the quality improvements are of course limited. But just for the sake of science, let's also try out 3DE's old Anamorphic degree 4 distortion model. So once again, import the grid shot, select Anamorphic degree 4 and enter all other parameters as before. To give it a fair chance against its degree 6 opponent, we will leave quality at max. Now let's compare. While 3DE's degree 6 variant at low quality still looks good, the old Anamorphic degree 4 model obviously has reached its limit, up to a point where it can't handle such extreme distortion properly anymore. For best possible results, we recommend to use 3DE's Anamorphic degree 6 family of distortion models, at least for extreme scenarios, like demonstrated in this example. Finally, let's discuss a topic which has been on our agenda for quite some time now. During the last 10 years, we have come across grid shots which show checkerboards containing variable grid resolution as shown in this example here. Let's try to import it using some standard settings for analog film cameras. 0.26 cm lens center X, pixel aspects of 2 and focal length of 40mm. Since this is a multi-resolution grid, we enable the respective option as well. After the import process has been completed, we once again can see that every matrix point has been set correctly. It also seems that distortion has been successfully calculated as well. Now working with this kind of grid shot shouldn't be that much of a hassle anymore. However, let us use this opportunity to discuss these grid shots in general though. Honestly, we think that these shots make no sense at all. There are a number of reasons why this is the case. The most important one being a very bad distribution of sample points. Usually, in the middle of the frame, distortion is more or less unnoticeable, whereas it becomes much worse towards the edges of the frame. In some cases, like the Technovision lens shown previously, distortion can become really extreme. These grids, however, provide their most details in the middle of the frame. At the edges, they usually show only very little detail. In this particular shot, for instance, there are only 9 visible sample points. This makes it hard to calculate lens distortion precisely out of such type of grid shots, and therefore we recommend not to use them at all. For the last part of our distortion update, coming with 3DE4 release 7.1, we are introducing a new distortion conversion script. It allows the recalculation of distortion parameters in cases where filmback size of the actual footage differs from the original filmback used for calculating distortion in the first place. To start, let's make some preparations. At first, we create a new reference camera, select it and then import a grid shot through Attribute Editor. We will use the Technovision grid that you already know from an earlier part of this video. For a better understanding, we disable the matrix and enable the field of view. Next we import a pre-calculated lens by the help of the script import lens. file Technovision_40mm should fit well to the previously imported grid shot. As you can see, all calculated distortion values for the lens have been imported. Finally, we can delete the sequence camera. To conclude all previous steps, we have to assign the newly imported lens to our grid shot. This can be done by selecting our camera and right-clicking on it. Context menu, Modify Lens, shows a list of all available lenses. We choose the Technovision one as our lens now. We immediately see that the pixel aspect has been correctly adjusted. When we undistort everything, we also notice that distortion is being compensated well, too. Now all is properly set up for our new script. For demonstration purposes, we use script copy frame to reference frame to create a perfect copy of our current reference camera. Next, we make the camera the current one, use F2 or go to Manual Tracking Controls, and under Menu Edit we select Set Field of View. In the upcoming Requester window, we modify the field of view in order to simulate a different filmback size. We enter 1090 into the first text field to make the field of view width 20% smaller. The second text field receives 595, which equals to a field of view height reduction of 10%. Once we hit OK, the field of view lines of our display area now show the modified field of view clearly. However, if we now go back to F3, we see a completely warped and broken distortion. You can compare it very well with the original reference camera to see how horrid it looks. What happened is that the original distortion values no longer fit to the modified field of view. For that, they need to be converted first. To do this, we create a new lens to store the to-be-converted distortion parameters and assign it to our second reference camera. Now it's time for our new script. You can find it in F3 under Menu Edit. Just look for Distortion Conversion. In order to use it, we first have to decide where our to-be-converted lens distortion data should come from. In our case, this means we have to select lens Technovision 40mm again. As you can see, filmback and pixel aspect has now been set up automatically. Within the topmost graphics preview, the green frame represents the original filmback in respect to the footage of the current camera. Next, we have to enter the corrected filmback size of the to-be-converted camera, which fits to the previously modified field of view. As you might remember, we reduced the field of view by 20%. That means we have to reduce the original filmback width by 20% as well. 4.02389 cm minus 20% equals 3.2191 cm. Analog to that, we also reduced the field of view height by 10%, which means 1.8672 cm minus 10% equals 1.6805 cm. Now say that 3 times fast. Anyway, finally we have to enter the pixel aspect of the to-be-converted camera as well. Since we haven't done anything to our pixel aspect, we can just enter 1.5. If we now take a look at the graphics preview again, we can see that the orange-colored frame, which by the way represents the field of view of the to-be-converted camera, now shows a similar picture as the field of view shown in display area. The top and bottom field of view lines have roughly been moved 5% towards the center of the frame, whereas the left and right hand lines have been moved by 10%. In addition to that, the green-colored frame, which represents the field of view of the original camera, is sitting exactly on the borders of the frame, just like it does for our first reference camera. So everything looks reasonable now, and we can convert the distortion parameters by clicking on button Reformat. The undistorted footage now looks good again. When we slide between the frames, we can see that the field of view is bouncing around. But the distortion is not changing at all, and the script is working like intended. If we toggle between the lenses assigned to both reference cameras, we can also see that the distortion parameters are indeed significantly different. We now go even further by adding a third reference camera. For this, we first import a cropped version of the Technovision grid shot. As you can see, it's still more or less the same grid shot, just, well, cropped. The reference camera has been linked automatically to the default lens, so no need to create a new one here. Once again we head to our distortion conversion script. The Technovision 40mm lens is still selected. The only thing to do now is to enter the proper filmback values, which match the physical cropping of the footage. To keep things simple, we have cropped the grid shot exactly the same way as we edited the field of view before. 10% of the left, right and 5% of the top bottom has been chopped off. That means, just like before, we have to enter 3.2191 and 1.6805 cm as the new filmback, as well as 1.5 for pixel aspect. The graphics preview now shows an orange colored frame sitting exactly on the borders of the frame, just like in the display area. Furthermore, the green frame is located outside the borders of the frame, roughly 10% to the left-right and 5% to the top-bottom. Everything looks plausible again and we can hit reformat. Undistorting and switching from frame to frame, we can see a small jump coming from the cropped off-center area. But except for that, the distortion looks correct and like intended. For the last example of today, we will create a new project. By the help of script import multiple reference frames, we add the Technovision grid shot once again. As usual, we select our new Anamorphic standard degree 6 distortion model. Enter 1.5 in text fields, squeeze ratio and pixel aspect, and finally set focal length to 40mm. Now we can import the grid shot with automatic distortion calculation enabled. As you can see, it looks like as if distortion has been determined correctly. Like we did before, we will now reduce the field of view by 20 and 10%. For this purpose, we head over to F2 and use script set field of view again. When heading back to F3, distortion of course isn't working anymore, just as expected. Now it's time again for our distortion conversion script. As usual, we first have to select a source lens from which distortion parameters should be taken for the upcoming conversion. Let's try to select the lens number 2, which has been successfully calculated just moments ago. Something doesn't look good. At least the filmback width seems to be very wrong. In addition to that, there's no green frame being displayed within the preview area anymore. This problem is caused by the fact that editing field of view has an impact on the actual lens. In this case, filmback width is set to passive in the attribute editor, and thus it is automatically being made consistent to any field of view changes. Now, how can we solve this problem? We could just enter the correct filmback size here, of course. But does anybody actually remember the correct value? As an alternative, we can import the Technovision lens file which we used in the beginning of this section. To do so, we hit Browse Lens File and simply select the respective file from the file system. Our filmback parameters seem to be correct again, and in addition to that, the green frame has reappeared in our preview area as well. As for the remaining steps, you already know the drill. We enter those corrected filmback values one more time. 3.2191 and 1.6805 cm. Pixel aspect is already set to 1.5. The preview looks pretty plausible from here, and so it's time to reformat this fella. As expected, distortion has now been successfully converted. We hope this tutorial about our new lens distortion features was and will be helpful to you. See you again in our next tutorial.